All right, so today we are going to start our polynomial chapter. Start talking about graphs of things that go higher than x squared. So we just need to learn some basic rules and some language before we start that. First off, if something's called a polynomial, that means a couple things. It means all the exponents of your variables have to be integers that are greater than or equal to 0. So for example, whole numbers. If you see a fractional exponent of a letter, it is not going to be a polynomial. So pretty much the things you would like to see. We like to see whole numbers and we like to see positive numbers. So chances are if you don't see that, something in your brain will tell you that doesn't look right. So we like nice friendly numbers in the exponents of our variables. If not, it's not a polynomial. It still needs to be a function, and if you forget, a function means that for every x value, you have one y value. Or in other words, when you put a certain number in for x, you get a certain number out for y. And you only get one answer for y. You'll never get a different answer. So some teachers teach kids to use the vertical line test. So if you forget, right, if I draw myself a line, the vertical line test just means that you would construct a vertical line anywhere you want, and we're looking for that line to only touch once. So there it touches once, 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 once. So this linear equation is a function. If I were to draw a circle, for example, if I draw a vertical line, you will see that it touches the circle twice. So let's say that this x value was a 3. Well, when I put 3 into whatever formula goes with this circle, I actually get two different answers. So my input actually generated two different y values, two outputs, and that means it's going to fail the vertical line test. So we want to make sure that that our polynomials functions meet those two criteria, that they are indeed functions and that the exponents are pretty whole numbers that are not negative. I also like to put in a little bullet point that you can't have any variables as exponents. So you can't have like x to the y power. All your exponents have to be actual numbers. So if we look at letter A, right there is a violation of the first rule. We have x to the 1/2. 1/2 is not an integer, so that's not a polynomial. Letter B, it may look weird because you have a root 7, but it's an x squared, so it is a parabola. All parabolas are functions. And 2 is not violating my exponent rule. So yeah, that is a polynomial function. C is in violation because of the negative exponent. And letter D, let's see, we have a 4 and we have a 3. And we're going to learn later that this is going to overall kind of look like a parabola. So it is going to be a function. So yes. So for right now, we're just checking these exponents and making sure that they're polynomial functions. Leading coefficient would be the number that's in front of the variable who has the highest exponent. So if you have x cubed and x squared, we would use the number that's in front of x cubed as our leading coefficient. So we will practice just identifying this information. It's pretty straightforward. The degree of a polynomial is whoever has the largest exponent in terms of a variable. So if you have like x to the 5th plus 5 to the 10th, 5 is not a letter, so we don't pay attention to that when we're classifying. We would say, oh, the degree is 5 because it's x to the 5th. If you had x to the 5th plus x to the 3rd, 5 is more than 3, the degree is still 5. And then standard form is just when you put your exponents from highest to lowest, from left to right. So if we have x to the 5th, x to the 4th, and x to the 3rd, that's the order we want to present it. So we always want our exponents to be in descending order. So the most common types of polynomial functions we work with have the following degrees: 0, 1, 2, 3, and 4. So it's very rare that you get something higher than 4 as an exponent. You can, but we usually see problems in that realm in terms of exponents. So the names of these guys would be constant. So for example, if you have x to the 0, that's the same thing as just 1. And if you were to graph the line y equals 1, it's just a flat line. If you have x to the first, and that's the biggest exponent, that's going to make a line. So you actually learned these in Algebra 1. So you started by graphing constants or linear equations. Now that you're in Algebra 2, we've moved on to x squared, which is quadratic. You have x cubed, that's cubic, and x to the 4th would be called quartic. Anything that's higher, we just say a polynomial of degree 5, polynomial of degree 6, polynomial of degree 7. And then we'll just do an example of each one. So for example, f of x equals 5, f of x equals 2x minus 3, f of x equals x squared plus x plus 1. So you can see 2 is the highest exponent. X cubed minus x, 3 is the highest exponent, so it's a cubic function. And x to the 4th plus x squared minus 10. So I just made these up, and I'm just getting you to realize, first off, these are all in the correct order. We want our exponents to go from highest to lowest. The highest number is the degree of the polynomial. The highest exponent is the degree. So this will be kind of like some homework questions you'll see. They'll ask you one to decide yes or no, is it a polynomial function? And if it is, we want to put it in standard form. We want to know the degree, the type of function, and the leading coefficient. So they want quite a bit of information, so you really have to know how to classify your polynomials. So first off for A, yeah, it's following the rules. These exponents are nice and pretty. It actually already is in standard form. The exponents are in descending order, so that's kind of done for us. It is a degree 3. So 3 is the highest exponent, and that is called a cubic. So you would say it's degree 3. Anything that's degree 3 is called a cubic. So the type of function is a cubic function. And then the leading coefficient would be the number in front of x cubed, and that would be -2. Letter C, I'm actually going to jump sideways here to letter C. It's not a polynomial because of this -1. So the good news is if it's not a polynomial, you don't have to write any of this information because all this information is for polynomials. So you're off the hook. Letter B, even though it has a root, we look at exponents. We have 3, 4, and no x's. So yeah, our exponents are good. We would want the x to the 4th to come first, then the x cubed, and then the 12. So there's your standard form. The highest power is 4. And if something's to the 4th power, it is a quartic function. And the number in front of x to the 4th is √2, so that's the leading coefficient. And then for letter D, it's not a polynomial because we have a violation right here. We have a letter in the exponent. So all exponents have to be numbers, not variables. So then we're off the hook. We don't have to write all of this information. So I actually really like when I get problems that aren't polynomials. It means less writing for me. So in my next video, I'm going to go ahead and take a turn and we're going to talk about end behavior of these polynomial functions.